Hey, so I'll start doing the homework 5. It's quite late here, 10:50, and I have time till 8 a.m. to solve this. But I need to make sure that I'll record my solution because I need proof that I did it on my own. Okay. So first we'll go through homework practice problems to understand what do they expect. Hmm. Describe which output you're passing to, how you take content. Include description of algorithm and words. Explain correctness of a design, state and analyze running time of a design. Unless I take the input graph G. Okay, so you just have to explain it. That is so much better. So topological, multiple statements about MST. Okay, let's see what the solution is like. 2 is 3 point. C algorithm examples. How is this practice problem? This doesn't tell me how to actually. Okay, this is 4 3.15. Computopia. This is good. Police department has made streets all way. The major mayor contends that there's still a legal way, but the opposition is not convinced. Computer programs. Okay, so basically you have to decide whether you can reach every place from every place, right? So intersection is nodes. You just have to make sure it's strongly connected. Is that the problem? So we'll represent graph G. Whether we can solve this problem by running SCCG. There is a single signal by A checking that every vertex has the same one checking the return level strongly no single vertex. If the entire G is okay, so I'll have to see how they define this strongly connected as well. So basically SCC returns which order they are found. So basically, okay, cool. Okay, which are source, sync, and metagraph. Okay, so we can do this by either checking that every word has same CC num. CC num is CC num. Every word. Okay, cool, fine. So what's the actual problem? You're given a directed graph where every vertex has a label C of V greater than 0. Design algorithm return for each vertex V the vertex W of minimum label reachable from V. Here, reachable means there's a path from V to W. You may assume that V is reachable from itself. All right. So basically, there's a graph. Everything we have directed graph. It's connected, and all of them have some values. We have to find the minimum reachable one. Okay. So we have to explore the entire graph, right? We start a DFS from V. We'll keep on doing DFS and we'll keep on exploring till you explore everything, but we'll keep a minima of the minimum one reachable. I think that's it. So it's DFS. That's all. Reachable from V. So yeah, we just do DFS. Fine. Okay, I'll write it. What's up? Homework 5. How do we let's just use this kind of language. Okay. Ah, and let's use the question. So, okay. The question is this. Answer. Uh, we are given a directed graph G is equal to V comma E where every vertex has a label C of V written 0. we have to return for each vertex v the vertex w of minimum label reachable from v. So what we can do is we can do a DFS from every point, and that will be O v square. But is that the best thing possible? Um, so what if for every point you can retain um, what's the best thing we have found so far? So let's say we are doing DFS. We will have to explore edges. Okay, so no, so reads about strongly connected components. Let's see. Let's say we do topological sorting. What happens then? So if you do topological sorting once, then we'll start from the best source. Nobody else is the source from there, so everything is reachable from there. And using that source, you'll find the minimum reachable. That's the value of that one. But the other ones, okay, what if we separate them into strongly connected components? That means that every strongly connected component. Okay. So what is the complexity of strongly connected components? We have to figure out for every vertex what is the minimum value reachable. This problem would be easy to solve if it were given that the graph was strongly connected. In that case, we could start from any. Why am I rotating? We could start from any vertex and do a DFS, and we would have discovered the minimum node true for all of them. So what we need to do is divide the given graph into strongly connected components. Then for each component, run a DFS. Okay, what all things that do you have to tell? Description, to description, explain correctness. Description, correctness, runtime, complexity. Run a DFS. For each component, you would have identified the minimum value for that component. Since since every node is reachable from every node in a strongly connected component, we can just choose one node to do DFS from, and we would know the answer for every node in that component. So if we run DFS for just one node per strongly connected component, we would know the minimum reach. So minimum value discovered, and the final minimum value after exploring all nodes is the minimum reachable for each node in that strongly connected component. So if you run DFS for, we would know the maximum reachable for each node in that strongly connected component. Now just do it for every strongly connected component. We first run SCC and then do DFS for each SCC. Runtime complexity for SCC. Hmm, ओवन n plus n क्या है इसमें? N intersections and roads. Okay, O of V plus E. V plus E. Now, if we do DFS for every SCC, we must also take into account that every SCC will be a subset of the original graph and each subset is mutually exclusive. This means that if V dash and E dash be the vertices and edges for a particular uh, SEC, DFS complexity, DFS runtime for it would be O of V dash plus E dash, but also sum V dash over all vertices equal to V. Sum E dash over all edges to E. Thus, sum complexity, sum. Am I writing this correct? I don't know. Complexity over all for for doing DFS for all SCC equal to O of V plus E. Thus, overall complexity is O of V plus E. Am I done? Fine. Looks good, right?